Hello, this is Ms. DB, and in this lesson we're going to go over relations and functions and domain and range. This is from Chapter 4, Section 2 of your textbook. Our objectives are to identify functions and also to find the domain and range of relations and functions. Vocabulary that's important is relation, domain, range, and function. A relation is what you saw in 4.1. It's just a set of ordered pairs or a graph. It's really any kind of relationship between x and y. Nothing special has to happen in order to be a relation. So here's an example. In the scoring systems of some track meets, for first place you get 5 points, for second place you get 3 points, and for third place you get 2 points, and for fourth place you get 1 point. This can be shown as a relation with a set of ordered pairs. So if we wrote that as first place 5 points, second place 3 points, third place 2 points, fourth place 1 point. That's a relation. You can also show relations with tables, graphs, and mapping diagrams. So let's look at some of the different ways that you can see a relation. Now you don't have to do this on your homework because it's hard to do in the online world in a worksheet, but you should know that these are the different ways that relations and also functions can be shown. So they're saying that we've got a bunch of ordered pairs, 2, 3, 4, 7, and 6, 8. And they say show that as a table, which means an XY table, like a T-chart. And you'll put the X's here and the Y's here. So when you fill it in, you would get 2, 4, 6 for the X values because they come right from the coordinates. And then the Y values would be 3, 7, and 8. So that's how you would express this relation with a table. You can also express it as a graph by drawing an X and Y axes and then putting points at 2, 3. Remember, you go over first, X, 2, and then up 3, then go over 4 and up 7, and then go over 6 and up 8. So that you can express it as a graph. And a mapping diagram looks like this. You have two kind of oval shapes, like ovally box shapes, and under the X box you put the 3 X's, 2, 4, and 6, and under the Y's you put the Y's, and then you draw an arrow that shows that this 2 went to this 3, this 4 went to this 7, and this 6 went to this 8. So you draw arrows just from one to the other, showing that those are the ones that are paired together. All right, now this is the really important part of this lesson, is domain and range. This is the crucial part of this section. The domain is the set of X values. The range is the possible Y values. So if it's a coordinates, if they're just listing points, the domain is the X values and the range is the Y values. If they're giving it to you as a discrete function, which remember discrete is when they just give you a list of points, like you can't have the decimals in between, it's just certain points, then you will list the domain as with commas between them and just the numbers that are possible. So these are with discrete. Domain and range will be listed that way. But this is a continuous function here. If it's a continuous function, which is when it's a line or a curve, then your domain and range are listed differently, because all the possible X values are not just 1, 2, 3, and 4, and 5. All the possible X values are also, 1.4 and 1.5 and 1.45, everything in between there. So when you have a continuous function, the way that you write the domain, you can do it in words. You can say from 1 through 5, or you could write that X is between 1 and 5 this way. So this shows that X is greater than or equal to 1 and less than or equal to 5. And the range in this one, you could write, let's see, the range values are the Y values. The smallest the Y value ever gets is 3, and the biggest it ever gets is 4. But there's lots of values in between for Y, so you can't just say it's 3 and 4. So you would say that the range is that the Y is in between 3 and 4. Now on your keyboard, you can make the less than signs very easily. It's just to the right and up above the space bar, and then you can use the underline function to underline it and so that it's less than or equal to. Since they have solid dots at these 2 points, you would want to include the 3 and the 4 for the range. So the domain there, they show it written the same way I wrote it, and they show the range written the way I wrote it. That's the easiest way to write domain and range for a continuous function. All right, these are your examples from your assignment. 3 of these are discrete. 1 of them is continuous. The discrete ones are 7, 8, and 9. For each of those, let's just do number 7. For the domain for 7 and for 8 and for 9, you're just going to list the x values with commas between them. -5, 0, 2, and 5. If any value appears more than once, you only have to list it once. The range is just the y values. Whoops. So the range would be 7, 0, -8, and -20. And because these are just a list of coordinate points, it's a discrete function, and we would not need the less than signs. So that's it for number 7. And 8 and 9 are the same way. You list your x values with commas between them. You list your y values with commas between them. If there's any number that appears more than once, you only have to list it once. But 10 is different because 10 is a continuous function. So your domain for 10 is all the x values, and you can do it in words if you want, between and including, because it has solid dots at, between and including 0, 2, 1, 2, 3. Or with symbols, you can write that like this. X is between 0 and 3. And the range is written similarly because this is a continuous function. The range is all the numbers from 0 to 3 again. So it's going to look exactly the same, except you'll have a y in place of the x. It's also going from 0 to 3, the y values are. Okay. All right, let's see if you can figure out the domain and range of this one. The domain, they don't have x values on here, but these are the x values, these are the y values. So this is a discrete function, so your domain is just going to be a list of all the possible values. And the range is just going to be a list of the possible values. So you'll just use parentheses, those kind of fancy brackets, with commas between them. Same thing for this one, because this is just a list of values in a table. So your domain and range will just be listed with commas between them. Notice in this one that there was 2 different numbers for the range, and then they repeated the 1. They only wrote the 1 once. Okay, a function is a special type of relation that pairs each domain value with exactly one range value. This is one of the most important vocabulary words of Algebra 1, function. Each domain value has one and only one range value. So each domain, let's list our domain here. The domain is 3, 5, and 4. There was 2 3s, see? The range is -2, -1, 0, and 1. The domain of 3 went to -2, and the domain of 3 went to 1. It went to 2 different numbers. It violates the rule for being a function because the domain of 3 is paired with 2 different range values. Now, if you would have had 3, -2 written twice, that would be okay. It can be paired to the same one more than once, but you can't have one domain value going to more than one range value. It's easier to see it when it's written like a map like this. So the domain, the x values are over here, and the y and the range values are over here. So let's look at this. -4 is going to 2, -8 is going to 2, 4 is going to 1, and 5 is going to 1. Now you might look at this and say, well, it's not a function because they're going to more than one, or 2 domain values are going to 1 range value. But the rule for it to be a function is that each domain value goes to one and only one y value. Each domain goes to one range. And this does that. Each domain value goes to one and only one y value. It's okay that some of the domain is being matched to the same range value. They could even all go to the same one. What you couldn't have is one of the domains going to 2 different ranges. If you had that, then it would not be a function. But it's okay for more than one domain to go to the same range. let's give the domain and range of this and then say if it's a function. So remember, this is continuous because it's not just a set of points, it's a continuous graph, it's a line or shape in this case. The domain is what we can let x, what x is in this graph. So the smallest x ever is, let's see, this is -3, -4, -5. It looks like the smallest x ever is -5. And then the biggest x ever is 1, 2, 3. So you could write that the domain is x values between and including -5 and 3. Or you can use symbols, put the smaller number here and the bigger number here. That's our domain. The range is that it is going from the smallest y ever gets is -2 and the biggest y ever gets is 1. So the range is -2 is less than or equal to y is less than or equal to 1. So y is between -2 and 1. Now, is this a function? If it's a function, it means that each domain value is paired with one and only one range value. Let's just look at the domain of 1. That's in our domain. 1 is in our domain. It's paired to 1 on the y-axis and also to -2. See that it hits at 2 places. This is not going to be a function because most of the domain values have more than one range value. All right, this says to give the domain and range of each relation, tell whether the relation is a function, and explain. So these are both discrete, so your domain and range are just going to be a list of numbers, and then you have to decide if it's a function or not. A is a function because each domain value is paired with exactly one range value. And B, you can list your domain and range, and it's not going to be a function because the domain value of 2 is paired with both -5 and -4. It's got more than one match, more than one range value. All right, so hopefully that helps answer any of your questions. If you have more questions, please come to my office hours at 2 o'clock on Monday, Tuesday, and Thursday, or make an appointment to see me at a different time, or just send me an email. Thank you very much.